Hello, and welcome to another edition of Containers from the Couch, where we talk all things containers and AWS. I'm your host today, Jessica Dean, and today we have a very special topic. We're going to be talking about ECS and Keyspaces. I have with me today Mike and Michael. We're going to start with Michael. Why don't you go ahead and introduce yourself?
All right, I'm going to try because we both have, we ran into this before. We're both Michael R. So we get a lot of overlap here. I'm Michael Rainey. I'm a specialist solutions architect here at AWS. I focus primarily on sort of NoSQL databases, but primarily on Amazon Keyspaces for Apache Cassandra, which is our managed Cassandra service where customers can take their existing Cassandra workloads and run them in the cloud, fully managed, fully serverless, and is really a great way to help customers modernize and move those workloads into the next sort of age of development. So it's really fun. Been helping customers, both running Cassandra from EC2 to containers and also with our managed service.
Awesome. All right, Mike, do you want to go ahead and introduce yourself? I know we have the same initials, but I know you do
Sure.
something a little different.
Hi, everyone. Yeah, I'm Mike Rizzo. I'm a solution architect based in the UK, in London, although I live out in the sticks in Suffolk on the East Coast. It's in the evening here, so we're spanning the time zones across the world. I'm a specialist. I'm a subject matter expert in containers, so I work a lot with both ECS and Kubernetes. I'm really keen on helping customers migrate to container platforms, and as part of that, looking at how we can take monoliths or legacy code and breaking that up, both in terms of the application code itself as well as the data. And I think there's really great synergies here between ECS and Keyspaces, and that's what we're going to be talking about today to help you with your migration from legacy applications using Cassandra to containerized applications with Keyspaces.
Awesome. Awesome. And just by the way, for anyone who is joining us, hello. Thanks for joining us live. If you'd like to share where you're joining from, feel free to post a comment in the chat. And also, if you have any questions or comments as Mike and Michael walk us through Keyspaces and ECS and databases and all those fun things today, please feel free to, again, add that to the chat. First off, let's go ahead and start with the big question. What is Keyspaces? What are Keyspaces? And why don't you go ahead and give us a little bit of a history? Michael, we can start with you.
I mean, really, the history goes back to probably, since AWS started, people have been running Cassandra workloads on EC2. And for the longest time, customers have asked us, can you help us run these workloads? Can you make this simpler for us? And in 2019 at reInvent, we launched Amazon Keyspaces, which is a fully managed serverless Cassandra compatible database. And now customers can take a lot of the heavy lifting of managing and configuring and tuning, and really move that over to for us to manage and handle for them. And it allows them to sort of break free from the traditional set of traditional database management and move more into a more agile, more modern, and we'll talk a little bit into it, how I think it really fits well into this microservices architectural pattern, which is so key to building and deploying apps in the cloud and moving quickly.
That's awesome. Yeah, I'll be honest. My background, having worked in operations and containers and different things before, I would not consider myself knowledgeable on databases. That part kind of scares me. And so hearing it as like you can actually be agile, you can like integrate it with microservices. That's both intriguing and slightly terrifying because I feel like, what's the catch? How do we make this easy? So I'm excited for this today. And it sounds like some of the use cases, like the why of why we care, is we're trying to simplify this, right? Like because databases and doing like a more agile approach has been challenging traditionally and historically. If we can simplify that and help users fall into success and meet them where they are in this new distributed systems, container, microservice kind of world, then we're going to be able to help solve that problem as far as agility is concerned and releasing faster, right?
Yeah, absolutely. And I think like what you're saying is like, I haven't really used databases, and that's historically, using a database has been just something that only a few people in the organization would be able to do, because there's so much risk traditionally around
Yeah.
operating and using the database, that from a skills perspective, from a utilization perspective, it's just not a very democratized sort of technology.
Right.
And what this is, it really gives you ownership back into the developer to say, hey,
Mm.
I don't really need an infrastructure team to set these tables up. I don't need someone to review this, before, or someone needs to, be the gatekeeper before putting this table in production. Really, these types of databases say, as a developer, you own the data model, and
Mhm.
go ahead, deploy it. And you will see the utilization in terms of consumed writes and read units. And essentially, it allows a lot of people to get more access to being able to run these mission critical scalable workloads, because that ownership is able to be changed, and the power is given back to developers.
That sounds really, really powerful and really interesting. Yeah, I mean, I have touched databases, but I'm not going to touch anything in production because knowing me, I'd drop all tables or do
Yeah,
something dumb. So,
exactly. Isn't that great? I'm definitely going to call that out, because that is one of the things where I think what we see is that we've talked so much about the application layer monolith, and we've dealt so much with the three-tiered architecture. We forget that sometimes the database is a monolith as well.
right.
And we need to decompose those things so that, if you drop your table, you're not going to drop all of the other tables, right? Or if someone drops their table, your database doesn't go down as well. So we want independent, isolated, well-defined sort of usages and domains that we can
Yeah.
build out scale, and multiple people can work into production without having the dependencies and gatekeepers, stopping us from deploying stuff to production.
Right. So it also sounds like it removes kind of the bottleneck when you are a developer and you're working on maybe a stateful application, or you have like a backend that's a database, whether, I mean, obviously in this case, we're talking about Cassandra, but the developer now doesn't need to submit a ticket, wait 2 weeks for IT to like set up a sandbox environment and then finally give their connection
Yeah.
string. And now it kind of, it allows the developer to iterate that much more quickly too.
Yeah. I mean, what I find when I work with customers, people who are running Cassandra, there's usually one person who's in charge of the entire cluster. They're not allowed to go on vacation. Not for everyone else to get into production. This person needs to know everything about what's going on in the database. And, it becomes this too big to fail. I don't want to touch it.
Right.
Yes, we'll add we'll throw more hardware at it to make it work. But, in terms of even, going through a configuration change to optimize it, becomes this challenge to do that. Like, well, the house of cards may fall.
Awesome. All right, so let's go ahead and kind of take a look at some key space stuff here and see kind of how this ties back over into containers and specifically ECS. I believe you kind of have some diagrams for us to be able to see.
Yeah, absolutely.
So let's see here. This is, we're looking, it looks like we have the agenda where we're kind of
Yeah.
reviewing users, threads, posts.
Yeah. So what really with the agenda really want to walk through is what we just started talking about, really microservices, and that's really the relationship here for ECS and Keyspaces, is that it's very common for someone who's maybe not only migrating to the cloud, but also wants to modernize that application. They're starting to think about, well, I know I'm going to have to transition this to microservices. So ECS becomes a really great platform, and containers are a great platform to do that a lot with these applications that maybe they built with Java or Node or Spring, and you want to start breaking that up and putting that into a containerized environment.
Right.
And then again, we have key spaces. So we see Cassandra also sometimes in this case is sort of it being a little bit of a monolith, and we want to sort of break that workload up and put it into a more microservices friendly technology. So that's how really me and Mike started meeting, right? So we started working with a lot of customers together, and it's like this is a pattern here, and we're finding that we're helping people. And I think that if we a lot of times about migration and getting started and having a successful journey to the cloud is about first understanding what technologies to use and
Right.
what does the future look like. And we're always looking for customer success stories and say, hey, this is what we've done, this is how we've done it, and this is how long it took. So that we were really trying to package that together. So, first part of this, we're going to really cover some of those things that we see, some of those trends that we see with customers, and some of the technology trends that we're sort of looking at and helping people, choose and adopt. We're going to go a little bit deeper and deep dive it. We're going to slowly get deeper into the technology, getting into Amazon ECS and Keyspaces and how specifically they can help. And of course, what I always like to do on these sort of shows is live demos. So put a little warning there, but we are going to do some live coding. We're just going to do some live deploy it. Do it live. Yeah. One of my favorite clips of all time.
Right. And it's like, fingers crossed, the demos gods be with me, please.
That is the image I should have put here instead of this. But yeah, this is going to be fun. So, we got actually a couple of demos. Me and Mike are also going to try to do separate demos here. And let's try to have fun with it. And again, questions. People have questions in the audience. Please reach out to me. Happy to make this more of an interactive session than your traditional, presentation host thing.
Right.
Yeah, one thing I'd like to add on this as well is security is so important. It's job zero at Amazon. And one of the things we're going to show you is we've got a SIG v4 plugin that we can use with Keyspaces so that you can use your ECS task role to control what permissions you have in relation to a particular Keyspaces table. So one of the nice things about the Keyspaces integration is that you get all the benefits of the standard AWS policies and very fine-grained permissions. And so, you can carry on using IAM in exactly the same way you may have done with other parts of your AWS ecosystem.
So it sounds like it's like a seamless experience as far
Absolutely.
as like you don't have to learn something new or reinvent the wheel kind of scenario.
Yeah.
That's awesome.
Yeah, it'd be shocked to see when sometimes I work. A lot of times, security is how much can we stuff into this VPC and lock down the VPC?
Yeah.
Everything inside the VPC is unencrypted, maybe unsecured, or doing these handoffs from IAM to maybe some Cassandra sort of authentication, which is internal and hard to manage. So I think, again, also just being able to get some of these native integrations, IAM, CloudWatch, CloudTrail, all built in from end to end is really a really cool step in the right direction.
That's awesome. And just one more thing, just to highlight on the security part is there's always somebody in the audience that will kind of like breathe a sigh of relief when they hear somebody mention security, because they're like, I'm not a security engineer. It's somebody else will take care of that. But I love that this is tied in, because whether you're more ops person or the artist formerly known as IT pro, or whether you're a dev or a DBA, security is everyone's responsibility, right? And the sooner we can shift left and have security be built into the process right from day one, rather than trying to like bandage it on and hammer it on at the tail end, the more secure we will be from a security posture and perspective, and the less reactive we will inevitably have to be. So I love that security is not only a thought, but it's treated just natively right from the get-go. That's awesome.
Yeah, absolutely.
All right, so let's take a look at monolith to the current state.
So this is kind of really, we touch really again, microservices, then we'll get into a little bit of technology, and then also then some live demos. So first, really, if you're unfamiliar, if we can go back in time, but still we're dealing with these things today. I think part of being a developer is part of being like an archaeologist, especially you walk into a new company and you have to go figure out, what they've been building for the last 10 years in an application. And, some characteristics of the monolith, right? And it's not really something that's identifiable, but you can sort of get it feeling for it when, things are challenging to scale. You have sort of all of these processes locked into a single sort of instance. And you can think about historically, it's been, when we started building these monoliths, you maybe had a few developers on the team. You didn't have access to just be able to create and deploy, containers and instances like dynamically and on the fly, and essentially doing with a few boxes. You were trying to continually scale those boxes up. And you started throwing all your application logic into that box because it was easier to add isolation into the application code itself. So you tried to use best practices in development and all your gang of 4 design patterns and try to build an application that was well defined and well architected in that generation. But as we get more and more data, as the systems become more complex, this sort of code became more complex to change and complex to scale. and you started having all of these dependencies on each other that created sort of like, if something was wrong with one of your APIs, something was wrong with all of your APIs, right? And that just gets more challenging as you add more APIs, which then snowballs into, well, it becomes more risky to change, and then you can't deploy to production as quick, right? So a lot of these things happen. You know, my past, when I built one of these too, and we had over 500 services, and you know, it became harder and harder to change, and it took a week before you can even get it going. So definitely have some battle scars here with monoliths, and it's a challenging thing to say, let me start breaking this problem up. Sometimes it's a boil the ocean scenario, but I think if we get the right technology choices, we can make this transition start to see much easier.
Awesome.
And all right, so again, where do we want to be, right? And that's essentially this microservices state. And again, this is one of those things, is like, yes, this is where we want to go, and we want to make sure that we get there, and when we get there, that it actually has the benefits there as well. So you know, you want to have, again, the characteristics of a microservice is really domain oriented. I want to sort of define the domain in which my service operates, and I want to try to build walls around that so that I can scale that and operate that independently. It's more cost effective and easier to scale that. And then again, one of the biggest, I think, benefits is that it's less risky in modification of those services. So you see this transition from, you know, users, threads, and post service. You know, you build in some sort of application form. Now, instead of that, you have your users service and your threads and your post most likely running in some sort of container, and you're able to scale these independently, so that, you know, as you have an influx of users, you scale the user service. Or if a single thread in your site is starting to become popular, you're going to want to scale that independently, and you don't want to scale all of the services, but you want to scale where the scale is needed, really.
Right.
Where do I need the resources to be applied to, so that it's the most effective in terms of cost, but then also availability. So this is really a lot of it's really, again, it's about reducing risk, and reducing risk allows, as I see it, you to move quicker,
Right.
get
You're more
things,
agile.
products to market, and also democratizes the access. Less gatekeepers, more developers, less fighting with the bureaucracy, you know, different you know, organizational dependencies, not only just, you know, the bits and the bytes and of physical dependencies when application codes or other services, but now you're dealing with, hey, I can't deploy this because X, Y, and Z deployment's going on, and you know, you gotta wait for this team to change this, make this change. You want these things to be independent, isolated, and be able to, you know, kind of get there with less risk.
Absolutely, yeah, and this is a very good visualization of what we mean, like, when we're talking about decoupling the monolith and, like, breaking things out, and focusing on that scale and being able to scale individually where that scale is needed is really powerful as well.
Right. So, you know, again, where me and Mike started getting together is that, you know, with customers, Mike's works directly with customers to help them kind of move to containers. And a lot of times they're using containers, and they're also using a database, and they kind of want to look at a path, and the path of migration, and which way they're going to go. And you can see here, we talk a lot about this on our AWS blogs, is there's certain paths to modernization. And some of the more popular ones, right, is obviously the relocate, move those applications to containers, but also options in terms of moving databases, whether it's rehosting it, or refactoring it, you know, taking your application and totally ripping out the guts and putting in new and putting in new stuff so that you can use new services, right? So what me and Mike have been really focusing on is really this replatforming thread here then in the middle. So with our managed service for Apache Cassandra and Amazon Keyspaces and ECS, customers can take existing applications and sort of replatform them. And through that replatforming process, they're able to start, you know, having the challenges of building an isolation moved into the responsibilities of the service, and allowing developers to sort of take more ownership of their applications and start breaking them up into microservices.
Yeah, I like that graphic. It really kind of shows the different strategies that you can
Yeah.
pursue depending on your scenario.
Yeah, I mean, organizations out there, they have a ton of different technologies they'll want to be moving to the cloud, and they want to sort of modernize.
Right.
And really, the first two stages here, really to discover what you're running, and sort of start looking at the right technology to move to, and then also what kind of path here you want to take. Sometimes paths will be a little bit longer, sometimes paths are a little bit shorter. But in this case, we find a lot of times that replatforming works allows you to keep a lot of the existing investment that you've already made in these applications and be able to repurpose them on these, managed services
Right.
that you could, deploy ECS on Fargate, and we're going to sort of you can then spinning off a lot of ECS tasks and start breaking that monolith down into multiple different applications and multiple tasks. So it's been fun, and it's kind of a nice uh, path for customers to not only get started with microservices, but really have a long tail trajectory to continue that and modernize their applications.
Yep. Yeah. Actually, this is a funny comment here. We got nothing is impossible. It says the architecture looks very much like the London Underground tube map.
Oh yeah, right, exactly.
But it's true, right? Because there's different strategies depending on like what your business needs, depending on what services you're already using, what your configuration already is. Your strategy as far as how you're going to migrate changes. Like just like
Oh yeah.
everything, I feel like in tech is the answer sometimes is how
Mhm.
should I do this, and it's
Mhm.
well, it depends. So this is a good way to kind of visualize on how there's multiple roads that can ultimately lead to production.
Right. It might be doing this analysis and find that, hey, I want to move to DynamoDB or this. Exactly. It depends. You want to go to Neptune for it's actually a graph application, but you've been using a relational database. It's a great time to take a look and say, hey, where do I want to go? How do I get there? What's the nice path for me for right now and then also in the future?
Yep, absolutely.
Another nice thing about this as well is if you don't have time to make too many changes to your app, you can pretty much replatform quickly.
Right.
And then over time, you can gradually start to spot, where to invest your time in maybe breaking things up a bit more. And maybe choosing the right database for the job for specific tasks. And the nice thing about this is you can immediately get the benefits of a managed service, both for the application in terms of ECS with Fargate and also with Keyspaces for the Cassandra side of things. And then once you're on the managed service, you've already got yourself a lot of wins, and then you can focus your energy on improving the architecture and, if necessary, refactoring the architecture of the application afterwards.
Yeah, it's awesome. Yeah, it's a really powerful graphic to kind of visualize, and that's a good point too. That like whatever you pick initially doesn't have to be what you live with. It's what gets you started, and then you could scale and change and adapt and adjust from there.
Okay, great. So again, current state, kind of where me and Mike work a lot with customers is that, your application is sort of built with this 3-tier architecture, and not only is a relational database back there, but it can be something like a NoSQL database like Apache Cassandra. And with Apache Cassandra, similar to the monolith on the left, what you have is multiple tables residing within the same cluster. And these tables essentially share resources, on these nodes. So while it does help you with scaling those workloads and pooling those resources, after you add a number of tables and you add a number of applications, you start looking for ways of how can I break these workloads up and get more isolation again, start a lot of the bottlenecks start to come in, a lot of the challenges with you would recognize in your application layer, and your data model starts to be frozen in time. And then again, on the other side, what tends to happen is you start throwing infrastructure at the problem. Instead of now I'm going to be hosting multiple clusters, right?
Right.
And then to host multiple clusters, now you're creating custom tooling to do such a thing, right? And you're building out this centralized organization in your company. And again, now all the developers want to be moving the code. They want to be using the database, but because it becomes this huge risk factor or center for risk, only a few developers start to work with the database.
Right.
And fewer and fewer start working with the database, which sort of shrinks the skills with the organization. Sometimes those people leave, and now you're left with sort of a skills gap to make up for. So there's a lot of these trends that we see. And what we want to sort of start looking at is, well, again, just to highlight that Cassandra sort of story, in a relational database, there are relationships between data. You have joins, you have foreign keys. The data is related into the structure of the database. In NoSQL, tables are not related. There's no foreign keys. Data is denormalized. You generally have independent and isolated from a logical model standpoint tables, and there's no sense of joins. There's no dependencies. The only thing that's really has a dependency in this technology is the actual cluster technology that runs it, right? So again, going back to that other image, you have a sort of cluster of nodes that you have all of these tables deployed, and they're sharing resources. So really what we want to do is be able to run these tables isolated and independently to allow you to sort of add new tables, remove tables, change these tables without impacting all of the tables that you have in your organization. So that's really a huge factor. I think one of the huge benefits with moving to something like Amazon Keyspaces. Again, this is like our scalable, highly available, it's serverless, Cassandra compatible database. So you use the same open source standards, open source applications, toolings, drivers that you've been using for the last 10 years on Cassandra. And you essentially be able to connect that up to Amazon Keyspaces and start using those applications and tools. And it's not just about the code, but it's also the skill sets and how to create a Cassandra model, or how to query, using a Java driver or Python drivers, etc. And again, this is fully managed and provides you with nice levels of isolation at the table level, so that even if your table is consuming, hundreds of thousands of read requests per second, it's not going to take any capacity from other tables within your account. So if you have existing production applications and a developer or a line of business has a new function or application, they need a new table, there's no essential risk in adding that table essentially to production, right? Where essentially that is not going to have the classical forms of risk you would have with the Cassandra cluster. And then performance at scale. What we have is ability to the same sort of low latency that you have when you're doing 2 or 3 TPS should be the same latencies that you get at thousands and millions of TPS per second. And that's because we sort of handle the capacity, manage it for you in this cases, so that when you're consuming these read and write units is a measure of utilization for Amazon Keyspaces, we sort of have the capacity in the back end to perform the same sort of performance for those data and key lookups. So it's really a phenomenal sort of technology. If to think that you as a single developer you create a Node.js application service and take that from 10 TPS to 1,000,000 TPS, without the teams of people that it required to do previously, and the months of, getting the right infrastructure in place to do that, and the testing, etc. It's really a really quick way to, get things in a very solid production state. We have customers who had, done a few months of a POC before I'm going, live into production. So it's a really quick way to iterate and build something, and build something that is made for a huge scale. But hey, if the product was not successful, or the line of business or the service that the company was offering didn't get the traction that it wanted, it's very easy to take away and destroy it and move it away, or there wasn't a lot of investment to get to that scale. So companies really be able to move quickly, scale up and scale down as necessary. And really, it's really freeing for the developers to be able to now to sort of create and deploy and manage things in production without having to worry about, bringing down the house of cards.
Right. We do have Nothing is Impossible is asking, is there any flexibility in terms of other non-relational databases like DynamoDB?
Flexibility. I guess in flexibility, meaning migrating to Cassandra applications to DynamoDB.
Let's see
It's
if
kind of hard to get what flexibility would be, but generally the flexibility is really the difference between maybe Dynamo and Keyspaces is with Dynamo you have to refactor your application to work with Dynamo. And Dynamo is a wonderful technology, amazing for microservices. So the choice really is that I have this application. Do I want to rewrite the data access layer, or can I leverage a technology like Amazon Keyspaces and continue using that application with the already investment I made in the Cassandra technology?
hopefully that answers. If Nothing is Impossible, if that doesn't, please jump in to clarify your question a little bit more.
Can we get the depends alert?
Let me go grab that
Yeah,
real quick.
right.
Just like in true form, it always depends. Yay.
Yeah. So again, if you're familiar with Cassandra and you've used Cassandra in the past with Keyspaces, you can think about the roles and responsibilities are more at the developer level. What your table model is, what your Keyspaces model is, the JVM tuning, the storage, the node, the tuning, the patching, the upgrading. All of that stuff is what the service will manage for you. So you can think of Keyspaces. If you're familiar with DynamoDB, it's very similar in terms of where the key sort of basic abstraction is, and that's at table level. So I think we've taken some of the learnings that we've done with DynamoDB, and we've inherited them with Keyspaces. And this is really a fundamental way to do sort of microservices, is we know that developers want to operate at a table level. Cool. And now for one of the fun parts, which is, I think we're going to do sort of a little bit of a demo. And
Awesome.
what I'm going to be showing is the Keyspaces toolkit. So this is available as a Docker container, or you do it live. We're going to do it live. We're going to do it as it's available as a Python package, or you can use it in a container. So what we've done is taken a lot of the popular open source tooling like CQSH as a way to access your Cassandra database and your tables, and you're sort of looking into your schema and creating and doing a lot of the DDL operations. We've packaged that in a Docker container that you can pull down. And what's really great about the Docker container is that, again, it's going to benefit from having this, being able to be repeatable. It bucks the process up into a single unit so that all of the dependencies are the same. You're not fighting with all the Python packages on your box, etc. And then we've wrapped all the best practices for this tooling. So we pre-configure the configuration scripts, or we put the PEM file in there for SSL communication, and we've added some helpers in there. We're trying to make this a little bit sort of like power tools or something like that for Keyspaces. So I'm going to demonstrate that today. We're going to create a Keyspace and a table, and I'll show you how to do that. without having to provision any infrastructure, without having to set up any nodes. So we'll kick that off. And I'm just going to switch to another tab.
And where can for anyone who's curious and wants to try out that Docker container image, where can they go pull that image from?
Yeah, it's currently available in the Docker Hub, but we are working on getting it into the ECR public repository. So maybe in another month or so, we'll have it in the ECR public repository as well.
And
you
drop
can also
that link in the chat for everyone.
You can also download it on. It's also available and open sourced on GitHub.
Perfect. Yeah, actually, we had a very helpful viewer drop that in the chat for us here, and then made sure to repost that.
Okay,
you can just search for Amazon Keyspaces Toolkit on Docker Hub. Thank you very much. All right, so let's see here. So we're looking at
so this
your
is
instances.
Let me jump in here. So this is just my EC2 instance, and
Right.
we'll go in there and we'll I'll show you how we've pulled down the Docker container, what we did to configure it, and then we'll go connect to Keyspaces and start creating some tables and some Keyspaces. So I'll get into what those are as well.
Perfect. I'm going to go ahead and make this larger for everyone and let you go ahead and lead this demo.
All right, cool. Thank you. All right, so what we have here is just the EC2 instance, and we wanted to download this toolkit and connect to Amazon Keyspaces, create some tables. So,
and again, just for anyone watching, you are currently just SSH'd or connected over into that EC2 instance. So you're just doing this from your command line on a basic Linux box.
Absolutely, yeah.
Okay, cool.
So again, it's going to be a simple Docker pull command. You're going to pull this from the public repository. We've already, sorry, that is the wrong command. Here it is. I do have to update the container.
Tags are important.
Yeah, especially when you haven't done latest yet. So you have to do a specific version. Lessons learned. If you're creating some publishing containers, latest is not something that is done by default. So the image is already provided and downloaded. Then what I needed to do is configure the region. So what I did was, and this is going to be used for the IAM authentication. So I wanted to, on this local box, I wanted to modify the default region that we use.
And this is the region from your AWS CLI and the config file.
Yes.
Now, could you, if you wanted to override this, like let's say that you typically deploy to US East 2, but for whatever reason you wanted to go to West 1, could you use the region flag, -- region?
Yeah, well, yeah. So you'll have to pass that into the container.
Okay.
I believe. Yeah. So we can do that. You can pass environment variables into the container and change that. So yeah, so I just changed it for US East 2 before doing this this call. And then that's all you would have to do is then run this container. That will run the CQSH process internally that is pre-configured to connect to Keyspaces once you provide the actual region that you'd like to connect to. We use SSL. You have to use SSL with Keyspaces, no choice of using it without being encrypted. And then Mike mentioned this previously, but we're going to use a SIG-v4 authentication provider for short-term credentials. So this allows you to essentially use IAM roles to connect to Keyspaces. So if you configure either you assign these users to a role, or you can have a service instances tied to this role, and you can manage what that has access to in terms of Keyspaces resources.
And just to break down this command real quick, just for anyone who may not be familiar with Docker but does know databases, he's just running a basic Docker run command. He's running it in an interactive mode. We'll remove the container after he exits out of it, attaching a volume where getting his local AWS. So that's how he's mounting his configuration, his credentials over into root/hidden AWS inside the container. And then I believe the Amazon Keyspaces and SSL, those are flags that the container is going to recognize once that starts up.
Yeah, definitely. The process in that container is going to recognize that which is just standard open source Cassandra tooling. So you use a lot of this. Everything after I specify that root volume, I'm sorry, the image name is something that is just standard to the open source tooling,
Right.
and to connect to Cassandra.
Awesome. All right, it's officially doing it live. Come on, Docker.
Yeah.
And look at that, it's connected. Woo!
Solid. That's what's great about using a repeatable environment based on an image. Kick off this process, because I know that every time that I'm going to do that, quote, every time it should come up with the same sort of similar results. All right. So next thing we want to do is create what's known as a key space. Now, key space, where Amazon Keyspaces gets the name from, is sort of a logical grouping of tables. So you can sort of group tables together in what is called a key space. And a key space is, there's nothing essentially that will change mostly about the deployment of it, but you may want to, you can configure it. Sometimes there's some properties about a key space you can configure, and that will apply to all of the tables downstream. So you can think of it more of like a hierarchy. I define a key space, and in my key spaces is a bunch of tables. So I'm going to paste that in there. And you might recognize this, like it looks very similar to sort of a database language, traditional relational. So what really one of the powerful things about Cassandra is the CQL like interface. So you have a sort of SQL like interface to the database to communicate with it. So it's not only is it very easy to program, it's very easy to read and know what you're doing if you have sort of any 100 level experience with sort of databases. So I'm going to create this key space. It's called the geography domain, kind of wrapping around the microservices Mike's going to deploy later. This is sort of the domain of which we're going to deploy for our application. It uses a single region strategy. So we'll be deploying this within a single region. It gets deployed so that all your tables within this key space will be deployed across multiple availability zones in the same region, so that it's well architected and highly available. And then we're going to add some tags, and the tags can be used for security policies, or they can be used in the cost explorer to understand and get the what is my cost of this key space, which is really nice. Something that you really didn't have before is like when you threw all of your tables and all your key spaces in a single Cassandra cluster, the cost was the cluster,
right?
And you really don't have a fine-grained way of knowing like what exactly a specific table would cost. But now you can actually go back and really start to identify the cost of each service by using tags. So it's a really powerful thing. Although people may have not used tags before in Cassandra, it's going to be a very powerful way. And it's one of those things like we're lifting and shifting this existing code, but you have this opportunity to start leveraging these components that are going to make you easily transition or have sort of getting the benefits of microservices by using the sort of built-in and native integrations that we provide. So
you gotta close it.
Yep, yeah, gotta close it. So created the key space. We create resources asynchronously. So if I went to go create a table now instantly, maybe it would say, hey, this key space is not available yet. So it usually takes 1 or 2 seconds before we can then start creating tables.
So the key space is kind of like, and this is just again coming from my background of I am not a DBA expert. My level is not even 100 level; it's probably 50. I know how to do select star from whatever database or table and use. So a key space is kind of like you've just created a database called geography domain, and then now you're going to go create the tables within that database.
Yeah, exactly. Okay. Yes, very similar to the concept of like a database in
I'm putting it like I've used MySQL, and that's the extent. So
right. All right, so now we're creating a table. You'll see that I have the key space first of geography domains, and then we're creating a table countries.
Okay.
The primary key is expressed here. This is in NoSQL. This is how you look data up. This is how data is also broken apart across ever increasing scalable infrastructure. So this is the source of your main access pattern. So instead of you can select star, but you got to include the partition key in your where clause to be able to look data up quickly and efficiently. And this table is such like a key value access pattern. We also specify here a default time to live, and that is in seconds, so it's like 90 days. So after a while, data can expire. And then we've brought our tags again. We've added the tags here so that we can do the same security configuration or the cost explorer configuration. All right, so go ahead and create that table, and now what we can do is we can go view that in the console. We can go select. We can do our favorite select star query. It will be copying pasting during the show. All right. So again, there's 0 rows right now.
Okay.
Nothing's inserted, but we're able to go ahead. That just deployed a table. That table that quickly can already do around 4,000 write requests per second, 12,000 read write requests per second. Almost instantly. As you kind of use the tables, they learn from the utilization and they'll continue to increase your capacity. So let's say you get to 3,000 requests per second. It's going to say, hey, this table needs more capacity. And it sort of uses sort of a learning method to increase the capacity based on that. So it's ever a sort of expanding table based on your application traffic. And again, you're only going to pay for the operations and the requests that you make and use.
That's awesome.
And I think maybe we can jump quickly to Mike. Maybe Mike, you show
Perfect.
a little bit more about it.
Yeah.
A more advanced demo than my crud.
Yeah, no, that's. I think it's great to see how you can interact with Keyspaces through a shell type of environment. What I'm going to do now is show another demo where we're accessing Keyspaces programmatically through tasks running on ECS.
Awesome.
So what I'm showing you here is the architecture of this demo that we're going to see. You'll see that we've got a key space with a called geography domain, and we're going to create a table in there called countries. There's two things running in the ECS cluster. The first thing on the left here is a load data task. All this does, it's a kind of, think of it like a batch job that just creates the table and loads some data into it. So this is a kind of one-off ECS task that just does a load data job. And then once we've got the data in there, I'm going to run an ECS service called Query API. And this is going to be a service that offers a REST API. And this REST API will make the data in the table available through some get calls. You can either do a get/countries to get the details of all the countries in the table, or you can do a get/countries/ a country name, and that will give you the details for that particular country. Mm-hmm. So a simple demo, but it just shows you how you can use ECS tasks with appropriate roles to access the key spaces. So talking about roles, so what we're going to see is there are two roles created here. There's a write role, which the load data task assumes, and this gives the load data task permission to create a table and write data into that table. And then the Query API service is a read-only service, so we give it a read-only role for key spaces. And we use ECS task roles in exactly the same way as you'd use ECS task roles to control access to any other AWS service. So some of you may have already used ECS with Dynamo, for example, and you would already be familiar with this concept of an ECS task role. So exactly the same principle. So I'm going to run through this demo. I've set up a lot of this in advance already. So there is a CloudFormation template. This is all available in our AWS samples repo, which is referenced from the blog post that we mentioned earlier. The blog post also walks through all the steps needed to build this demo. Essentially, this CloudFormation template sets up what you're seeing here, which is an ECS cluster called demo staging. running across 2 private subnets. We've set up a Keyspaces VPC endpoint. So this is really important. You can, if you want to keep your traffic within your private VPC, you can use a VPC endpoint to keep the traffic local. And then we have some public subnets where we create an application load balancer, and this is to expose the REST API on the public internet. And then underneath that, we've already pre-created a geography domain key space and these IAM roles. What I've also done in advance, just to save time for the demo, is I've already pre-built the Docker images, both for the load data task as well as the query API service.
Awesome.
So, cool. So let's dive into setting all this up. So first of all, let me show you what we've got here. So on the IAM console, you can see I've got my 2 roles, a read role and a write role. If I click on the write role, you can see the permissions here allow me to write basically it gives me all permissions on these resources on the geography domain key space. I also have my container images in ECR already. So I've got one for load data and one for query API. I have a CloudFormation template spun up. Now, when I created this CloudFormation template before the session started, this created a lot of outputs, things like a cluster name, security group for the containers, URL for the load balancer. These are all values which I'm going to need in my demo. So what I've done is in my Cloud9 environment, I've actually exported all of these as environment variables. So for example, here's an environment variable for the ARN for the write role.
Okay.
So I've got all the data items I need ready in my environment here. So what I'm going to do first is, first of all, let's go to the Keyspaces console. You can see here there's a geography domain that's been pre-created, but at the moment there are no tables, right? And if I also go to my ECS cluster demo staging, there are no services running and no tasks running. Right?
Okay.
So I'm going back to my Cloud9 environment, and I'm going to start by running the load data task. All right. So what I'm doing here is I'm running a task in my cluster demo staging. I'm going to run it on Fargate. The task definition is load data. This has been predefined. And I'm saying this is where I want to run it in my private network, right? So I'll launch that task. And if I go back to my ECS console and do a refresh here, I should see under, this is running as a task, not as a service. So you can see my task is just being set up here. It will take a little while to get going. While we're waiting for it to going, we'll have a quick look at the task definition. You can see it's using the task role Keyspaces ECS write role, which gives it the right permissions. And it's running on Fargate. Okay, so if I go back here, hopefully now it's running. And if I go back to my Keyspaces tables and do a refresh here, you can see I now have a countries table, right? And what we can do is we can go to the CQL. And I'm not sure if I pronounced that right, Mike. Is it CQL? I always get confused.
Yeah, CQL, just like that.
Okay, so you can run CQL queries straight from the console. So I'm going to just put a select in there. And I'm going to run that, and you can see the load data container has placed this data in my table, right? So what I'm going to do now is I've got the data in the table, so I'm going to start a service now with to offer a REST API, so that I can access the data through my REST API. So what I'm doing here is I'm creating a service, again, same cluster, service names, query API server on Fargate. I've set up a task definition in advance, network config. I'm saying I'm going to run this with 2 tasks, and I've also specified a load balancer that I'm going to use. So launch that, and we'll go back again to our ECS console. If we can see that the previous task is finished. I now go to services, and you can see that I've launched this query API server. service. Again, this will take about 30 seconds or so for the tasks to get going. So the tasks are being provisioned. Again, while we're waiting for that, we can have a look at the task definition. And here you can see the task role this time is the read role. And then once our service, okay, we've got a healthy task here, so we should be able to go back into our console and start to use our REST API. So first I'm going to do, I've got a little endpoint here, which is like a health check endpoint, and which returns okay. That means the service is now live. And I can do a curl to test the REST API. And I've got the data for the US there. And another query here is to get all the countries in the database, and that's pull them out. So you can see I've got a REST API working on ECS, pulling data from Keyspaces.
Awesome.
We're running low on time, so there's just one more thing I want to show. Mike, you're going to say something?
No, go ahead. Let's get it.
Yeah.
No two demos, but out of fire yet. Yes, I'm happy.
Yeah. No,
and we're doing it live.
Doing it live. Yeah. So all this, as I said, it's all referred to from the blog post. You can get all these from blog posts. But I just wanted to call out the blog post itself points at this AWS sample, which is full of Keyspaces examples. So this particular example is in Node.js, but we've got examples in Python and Java as well, and Go as well. And this particular example is using the SIG-v4 authentication plugin. I'm not going to go through all the code because I'm out of time, but the key thing I want to call out is this the SIG-v4 here. So this is the plugin that we're using to do the authentication. And basically what we need to do is when we are setting things up, we use this AWS SDK call to get ECS credentials. So this essentially gets the credentials out of your ECS task. So it gives you temporary credentials for your ECS task. And you then create a credential provider chain from that. And that credential provider chain will be used by the SIG-v4 authentication plugin at the time you come to make the first call. So I then create this SIG-v4 object, and then I create a Cassandra client where I pass my authentication provider, which is this SIG-v4 authentication object that I created. And when you do that, essentially you set up a connection to Keyspaces. You're using the exact same Cassandra libraries, by the way, as you would for normal Cassandra. It's just talking to Keyspaces behind the scenes. And you're using this SIG-v4 authentication plugin to use your ECS task credentials. The rest of the code is just a standard web server using Express, for those of you who know JS. So this is just the code for my /countries, for my /countries ID, etc. It's all pretty straightforward. So yeah, have a look at this code. If you do have any questions about this, feel free to ping us on Twitter, and we'll get back to you.
Awesome. Wow, this was
back to you, Jessica.
Yeah. No, this was awesome. This is I mean, again, I told you my background a little bit. I'm familiar with just enough to be super dangerous around databases. So this is really cool to see like just how easy it is to get started. I mean, Michael, seeing your demo and seeing that, I mean, with just like 2 commands, pretty much, like you're able to create a Keyspace instance, generate tables, and you're up and running. And then Mike, in your demo, like we're able to deploy services on ECS, assign IAM roles just as we would with any other AWS service, and very easily be able to not only write into Cassandra databases within Keyspaces, but then also pull information back. And all of that was seamless and again done live. So the demo gods were with us. But it looks like I mean, I guess I should like knock on wood kind of thing if you're stereotypical, but I was going to say it doesn't look like there's much that can go wrong. Like you're using containers, you're using microservices, you're running the same commands, you're having things that are repeatable, and that really gives you that additional confidence where I can see how that risk has been reduced, which that was one of the #1 value props we talked about today.
Absolutely.
Awesome. All right. Well, we do have probably less than 60 seconds left. So I will say thank you, everyone, for joining us, for hanging out with us for the hour. Thank you so much to Michael and to Mike for walking us through that. It was awesome. I learned a lot. I know that those who were joining us live learned a lot as well. And I believe that will be it for today. Be sure to join us again for the next episode of Containers on the Couch. And thank you very much. Check out the repos that we posted. We
see you.
posted links to the blog post, the GitHub repo. If you have suggestions, you can definitely contribute and interact with Michael and Mike right through the GitHub as well. And thanks again. Have a great rest of your day, everyone.
Thank you.
Thank you. I'm going to get
Cheers.
a video here.